The standard states that outdoor air quality should be investigated prior to completion of ventilation system design in Section 4. To accomplish this, a regional air quality study and local air quality survey should be completed. For regional air quality, the standard requires the designer to determine compliance with national ambient air quality standards at the system or building location. Additionally, in the United States, status shall either be attainment or non-attainment. Attainment means the air quality is good with respect to a specific contaminant. To accomplish this, designers should consult the National Ambient Air Quality Standards, or NAAQS. A series of informative notes accompany this requirement. The NAAQS can be found online and is republished in Informative Appendix D. Non-attainment areas are available in the EPA's Green Book. Real-time, daily, and historical air quality data collected by the EPA is available online. So let's take a moment to look at the NAAQS. In the United States, the Clean Air Act requires the Environmental Protection Agency to set the standard for pollutants considered harmful to the public and the environment. Two types, primary and secondary standards, are identified within the NAAQS. Primary standards cover public health protection, including the health of sensitive populations, such as those with asthma, children, and the elderly. The secondary standards cover the public welfare and include decreased visibility and damage to animals, buildings, crops, and vegetation. So, as an example, let's look at carbon monoxide. The table shows this criteria pollutant is categorized primary. There are 2 time limits, 8 hours with a maximum level of 9 parts per million and 1 hour with a maximum level of 35 parts per million. And these levels are not to be exceeded more than once per year. This table comes from the EPA website, and ASHRAE republishes it in Informative Appendix D of the standard. The EPA sets the NAAQS for 6 aforementioned criteria air pollutants. The agency also provides a list of non-attainment areas, areas where 1 or more of the criteria pollutant levels are exceeded within its Green Book. Here, you can find lists and maps identifying those U.S. cities and counties designated non-attainment. Finally, Standard 62.1 says any area without an EPA-compliant status designation in the U.S. is considered attainment. So you might wonder, how would I use this? You can use this EPA website to look up the county where a building or system is located and determine which, if any, pollutants are classified as non-attainment. Next, Standard 62.1 requires a local air quality observational survey of the building site and its surroundings be conducted. Air samples should be taken at the same times as buildings are to be occupied to identify local contaminants that could be allowed to enter the building. Finally, the results of the outdoor air quality survey should be documented and reviewed with the building owner or owner's representative. The documentation should include a variety of items, including the date and time of observation, descriptions of adjoining properties, odor and irritant observations, and others. A conclusion stating the acceptability of outdoor air quality and supporting information should be provided. This information can be used to make informed air cleaning decisions. Okay, on to the next section, systems and equipment. This section contains many requirements which will help you specify equipment and systems. And while it's a misnomer to simply state that a product meets Standard 62.1 requirements, oftentimes manufacturers mean their products meet applicable requirements within this section. Here, you'll find a lot of requirements related to ventilation system design, outdoor air intake locations, particulate filters, coils, equipment access, air classification and recirculation, humidification, dehumidification, and many others. Section 5 could be an entirely separate program. So let's just review several highlights. Section 5.5 discusses the outdoor air intake location for ventilating systems. Here, the standard requires that outdoor air intakes shall be located at least a certain distance from potential contaminant sources. The standard provides a lookup table or calculation procedure in normative Appendix B. This is an excerpt of the table. Here you can see the potential contaminant source in the first column and the minimum separation distance between source and outdoor air intake. The standard provides an air classification system in Section 5.18. So for example, a designer might want to know the minimum separation between a commercial kitchen grease hood and a makeup air intake. The standard defines commercial kitchen grease hoods as Class 4, meaning the exhaust has highly objectionable fumes or gases with potential dangerous particles, bioaerosols, or gases at concentrations high enough to be considered as harmful. As a result, the makeup air intake should be at least 30 feet from the exhaust from the hood. In the latest publication, the committee added new requirements on ozone generating devices. The standard provides an informative note explaining that ozone can be expected from a variety of devices, including ozone generators, corona discharge devices, some UV lights, electronic devices with chemical reactions, and high voltage devices. It also exempts motors and relays. For devices that do generate ozone, Standard 62.1 now references UL Standard 2998. This UL standard limits ozone emissions from devices to a maximum of 5 parts per billion. Similarly, ultraviolet devices are not permitted to transmit at 185 nanometers because ozone could be generated. Recently, the particulate filter section was updated. Here, the standard requires MERV 8 filters to be installed upstream of any cooling and dehumidifying coil that has a wetted surface. So, if a device is producing condensate because it's removing moisture from the air, a filter must be supplied upstream of the device to help keep it clean. In the most recent update, an exception was added clarifying that any cooling coil that is designed and controlled to provide sensible cooling only is exempt from this filtration requirement. Next, the maximum indoor humidity requirements were changed in a significant way for the 2019 publication. Previously, the standard limited maximum indoor humidity to 65% relative humidity or less when analyzed at design dehumidification conditions. Now, indoor humidity is limited to a maximum dew point temperature of 60 degrees Fahrenheit whenever the outdoor air dew point temperature is above 60 degrees. So whenever it's humid outside, the indoor space humidity should be controlled, and this is during both occupied and unoccupied hours. On the psychrometric chart, it's pretty easy to see the space humidity limit. For reference, the dot shows where 75 degrees dry bulb, 50% relative humidity sits. You can see that the prohibited operation isn't all that far away. In fact, it's only about 5 degrees on the dew point scale. Exception 3 allows overnight periods with a duration of less than 12 hours to exceed the 60-degree dew point limit if the indoor relative humidity remains below 65%. Again, you can see the prohibited operating region shaded in red. Space dew points can exceed 60 degrees, the horizontal dashed line, but they cannot exceed 65% relative humidity for a period less than 12 hours. Exception 1 states that this maximum indoor dew point limit does not apply to buildings or spaces that are not equipped or served by mechanical cooling equipment. And finally, Exception 2 states that buildings or spaces that use components designed to resist microbial growth and are not damaged by high humidity are exempt from the requirement. Examples of such spaces might include shower rooms and spa rooms.